Hello, I welcome you to lecture 13. So in lecture 13, we are going to focus on attribute data. In our previous lectures, we have been discussing spatial data. And when we started this lecture series, we talked about two types of data in GIS, the spatial data and then the attribute data. We would want to focus a little bit about the attribute data. And today we are going to talk about the attribute data types. When we say the attribute data types, we are talking about, or we are using the criteria based on the storage, how data is stored within the attribute table. This is a slide that we've seen before, and in this slide we try to differentiate between the types of GIS data we have, the attribute or non-spatial data, and then the spatial data. And we said that the attribute data is actually the information that tells us about the location. It is more like the characteristics of the location or the features of the location. And there are five data types that we're going to talk about based on the criteria of storage. The first one is string, or you may also see character, or you may see text. You would also see float is also another type of attribute data. And then you see integer. There's also date and time, and then there's blob. Now we're going to take this one at a time and talk about them briefly. But just to highlight the most important things that I think you will need to be aware of when you are working with GIS data. The first one is text. Text are basically uh, values that represent, let's say, name of a street, name of a building, name of an object, and they are basically in the in plain text, like the way we would see ABC, ABCD. You might also find the term string, which is also used. You would also find character. It depends if you are using a database. If you're storing this in a database, different databases have the way of labeling this, so you can see any of this. And like on our right side in this image, you see that we have um, various texts that have been used to write the header or the column heading of the attribute. And like first name is going to receive an information, middle name is going to receive an information, and basically that's what text is. I think text is a bit more self-explanatory. I hope you get it. If you didn't get it or you have a specific question, kindly put it in the comment section and we'll do well to respond to that. The next one is float. So float, it's more like they are numeric values that are stored with their fractional values. So we would also always see a decimal, and there are some figures after the decimal. And so floating point or float data types are actually also used very much in GIS, depending on the data that you are storing, depending on the attribute information that you are storing. Floats can be a very significant value. For instance, if you are storing information about temperature, we do not have Y temperature in a short range. So you mostly have a difference in temperature of point something. And so it's important to keep the decimal values of the temperature values if you are looking at temperature. It could also be any other feature that has a very small gap in terms of the differences between their values. And so if the differences are that small, then the decimal becomes very important to use. One other thing that I want to draw your attention to is the fact that in computing or in the computer, the float is actually stored. There are two ways of storing the float. One is the single precision floating point format. This format is stored on the computer and it consumes 32 bits of memory in the computer. And then there's also double precision floating point, which also consumes 64 memory of the computer. Now, these two different formats have range of values they consume or they take. If you have a data and you are creating an attribute table, or if you are configuring a schema for your database, it is important for you to be able to understand which of them you need, whether your values you intend or the values you anticipate to store in that column is okay with a float 32 or it will need float 64. The reason is that if you don't do this, you would unnecessarily create large data when you do not need them. So if your values could have been stored in float 32, but you ended up using float 64, then your each values in your attribute table is going to consume 64 memory of your computer. And what that means is that it's going to increase the computation time. It's also going to increase the size of the data depending on the number of attributes involved. So 64 multiplied by any other memory that you need. However, there's a tricky part also to it. Sometimes the processes you are going to run on the data actually requires that the data should be in a 64 bit or in a floating point 64 format in order for it to work. So these are some of the background checks you would have to do, which is a bit tricky. But on the go, mostly I make these decisions based on the data that I'm going to store in it. So floating point is important, but there are two formats. Pay attention to whether you want a 32 floating point format or you want a 64 floating point format. Now we talk about integer. Integer are numerical values that are represented like a whole value. So you do not see point something or you do not see any values be with after that comes after a point. And when it comes to integer, there are two formats. We have the short integer, we have the long integer. Short integer basically allows to store values within certain range. Long integer also allows to store values that are larger than the short integer capacity. Another thing we have under the integer is the 32-bit integer. This is similar to the floating point. 32-bit integer also occupies 32 memory in your computer, and 64-bit integer also occupies 64 memory in your computer. Another thing you will see is signed integer. Now, signed integer is basically saying that a number can actually have the value of negative or positive. So if we use the temperature example again, if we have a temperature, we can have a negative temperature and we can have a positive temperature. So if we anticipate the column to have an information on temperature and we need a 64-bit, then we are likely to use signed 64-bit data type to store that information that we need. Sometimes you see 64 or 32 unsigned integer. What that basically means is that it doesn't consider uh, a minus value in there. These things are very important because they are very trivial and they are very, very easy to overlook. However, if you are creating data for a large data collection or if you are building a large database and you are not able to take these things into consideration, over time, recreating them after the data has been collected is very difficult. Also, it becomes sometimes impractical when you don't really pay attention to this. You start processing with certain operations and you don't understand the results that you get. And so when we say that if you take data from someone already and the column is signed integer, what it means is that that column can consume negative. So when you do any calculation in there and you get negative, you are not going to get any warning because that column, that data type stores in a negative value as well. However, if it is just an unsigned integer, it's going to prompt you that it can't store a negative because it's an unsigned integer. So this is what you see. It's like a matrix. You see the 32, 64, you see sign and unsigned. And then when you do the cross matrix, you will get several combinations of this. Date time. So date time basically in GIS we also consider time and then uh, time as part of the important information that we need. And the timestamp actually gives us a lot of information. Sometimes you would have the date and time in the same column, which is mostly recorded as date time. There are times where you will see them separated. So date is in a different column, time is in a different column. However, there is a data type that stores date such that it decides the configuration of the date, whether the date should start with month, year, and day, or year, month, and day. That configuration would be done already. So whatever you type in there, it will try to do a validation check on the data. And so it's important for you to define your column that is going to collect date to have a date attribute data type because it would increase the integrity of the data you're going to collect inside that particular column because it would make sure the data conform to the format that has been defined, whether year, month, and day, or day, month, and year. It's going to make sure that that is done well and so create consistency across your data collection. The last one I will talk about is a binary large object, which is called the blob. The blob is actually used for storing multimedia informations or like images. So sometimes you collect data and you take pictures of so you collect a GPS data and you take pictures of whatever you have taken as part of the attribute informations that you provide. It could be that you want that attribute information to be part of, you're going to use the data for a web application and you want to show pictures and stuff. Now, the way the computer stores, or the way in GIS we store the data such that we can relate the picture to the, the location is to store it with a reference link. So it's like linking it to the object that you are trying to collect this images on. So you are going to have that data column. It's supposed to have a blob data type. So if you are creating a data for field work and you anticipate that you're going to take pictures as part of your data, then it requires that you create a column. You can call it images, you can call it pictures, you can call it anything you want to call it. But that column data definition should be a blob because a blob is what is the kind of data type that allows you to be able to store an object link or an object embedding or embed an object into your data. I know this sounds very um, simple. It might be something you have seen before. It might be something you have been overlooking, but we pay attention to details very well when it comes to some of these because in GIS, the attribute data is used for a lot. We run operations that are mathematical. We run some operations that requires that we add, we subtract, we do ratio. And if we are not really certain about the data type, the embedded data type of the attribute columns, sometimes our algebra, mathematical equations, and other things we run on them gives us wrong results and we don't really understand why. Sometimes they don't even run at all. We get an error because you have a field type that is a text, but it has in figures like 1, 2, 3, and you assume that because it's 1, 2, 3, it's an integer. You go ahead and run a ratio formula on it, and it's not working. It's because the computer doesn't see it as an integer. It sees it as a text, even though there's 1, 2, 3 in there. And these are some of the things that it becomes very, very critical. And if you pay attention to those details, it increases the integrity of your work. It ensures some sort of confidence in your results and ensures that there's a consistency in your data. I hope this lecture has been insightful. In your one-on-one class with our instructors, they are going to take you through how to create attribute table, how to create columns, how to define these, and many other things. And you would also come to understand how to use this attribute data type to ensure what we call database integrity, so that your data that you collect would have some sort of quality check embedded in them even before you do an extra quality check when you finally get the data back. I hope to see you again in our next lecture. Until then, see you.